I thought, since I talked about how sites are the natural context of where to define sheaves, I might just as well also define what a sheaf is in a more general setting. So let C be a site, a sheaf on C is a functor, Fraktur F from the opposite category of C to set, satisfying, so that means it's a pre-sheaf, but it also satisfies these gluing conditions, and they can be summed up in one condition: let U be an object in C, and let Fi to from Ui to U be a cover inside the site C. Let xi let the xi be objects in f of ui, satisfying certain conditions that they glue well together. They can be summed up in: for every I and j in the index set, for every object v, and for every two maps f and g, one mapping from v into ui, one mapping from v into uj, such that fi composed with f is equal to fj composed with g. We have f of xi is equal to f of g of xj. If all of these conditions are satisfied, there is a unique x in f of u, such that the xi are just the restrictions of x. This condition here, we can view it as follows. So we have a cover ui uj of u, and then xi is living on ui and xj is living on uj, and then we have any other object in our category C, v, that maps into ui and uj such that this diagram commutes, meaning that it sort of maps compatibly into ui and uj, that sort of the restriction of xi and xj to the set v is equal. If our categories happens to have finite fiber products, this condition is equivalent to saying that if you take the fiber product of ui and uj over u, then again xi and xj come from the same object here. Remember that our functor is contravariant, so that we can really say that they map to the same thing here. In the case of all of them being open subsets of U, we can write this fiber product here, Ui crossed over U with Uj is sets of elements x and y in Ui times Uj, such that the inclusion of x is equal to the inclusion of y, but if we're just talking about subsets, this inclusion is just x and that thing is just y, and the condition that they lie in ui times uj just means that they lie in both ui and uj. So this is really just a fancy categorical way of talking about the intersection. So what this condition is sort of ultimately saying is that our objects xi have to agree on overlaps, and the fact that this is unique is basically the identity axiom.